In this video, we will do a brief introduction to the lab here, which is all about the t-test, and then we will look at the first example, which is about a new procedure called the Shapiro Test for Normality. So on this first page, I've got some reminders and definitions, and I think that's very much worth a read through. The second page, I have the steps that are required to perform a t-test, and we will go through a complete example of this. In one of these steps, we need to verify that certain requirements are met. There is going to be a new process for us in which we can verify these requirements. We know all about a QQ plot, right? But we now have another way to assess normality with what's called a Shapiro test. So that is what we're going to talk about in a moment. The following steps here are establishing the hypotheses, stating the significance level, and doing the computations. Step 4 is where R really comes into play, and then stating the conclusion based on the output. Let's look at this Shapiro test for normality. So this is what this first example is about, and I have uploaded the data into R, and I want you to notice that this data is grouped. So the angling effort column contains the quantitative values, and the column labeled day type gives what type of day it was, either weekday or weekend. Let's take a gander. I have named my data frame angle, so the quantitative values are in the first column, and they are categorized based on the info in the second column. It might be worth noting that the first 15 values are weekend values, and the weekday values are the subsequent values. So that starts in the 16th row all the way to the very end, which is 50. We can see that the weekend values have a sample size of 15. The weekday values, there are 35. We still want to check why the normality requirement is met in these samples. So we know all about the QQ plot. Because this data is grouped, we're going to need to specify which portion we are working with here. So I'm going to state 1 through 15 in hard brackets. So I'm going to make my QQ plot now, and this is for the weekend data. Now, does this look like a reasonably straight line? It looks like it deviates from normality. It looks like it has some sort of right skew. So we know how to assess these QQ plots. So we have that tool under our belt. Our new tool is going to be performing what's called a Shapiro test. This Shapiro test is its own little hypothesis test. It states in its null hypothesis, I have this written in the instructions. The null hypothesis for the Shapiro test of normality states that the sample came from a normal distribution. The alternative hypothesis for it is that the data did not come from a normal distribution. We do not want to reject the null hypothesis here when we have small sample sizes. And usually our threshold is comparing this p-value to 0.05. So even though this looks like it may deviate from a normal distribution in the QQ plot, the Shapiro test is allowing us to actually give us a more definitive statement that, hey, this is reasonably normal. So I'm going to make a note here that the weekend sample appears approximately normal because the Shapiro p-value exceeds 0.05. Now let's take a look at the weekday sample. So this is for the values starting from the 16th row up to the 50th row. This sample too, it seems reasonably normal, and it does actually have some right skewedness to it. Right, these QQ plots were established so that way we have a straight line is pretty easy to identify, right? But even then there can be some ambiguity. And that is why we are using the Shapiro test as a tool to assess normality. So this is now for the weekday data, Shapiro test. Looking at the p-value for this Shapiro test for the weekday data, that is a smaller p-value. This data, the weekday data, does not appear to be normally distributed because the Shapiro p-value is less than 0.05. Initially, that may pose a problem because, wait, don't we need this normal distribution? However, we can appeal to the central limit theorem since the sample size for the weekday values is 35, which exceeds our threshold of 30. So this is the process that you need to go through to verify the normality requirements in this lab and in future hypothesis tests for the t-test. The sample size is not an initial concern. The initial concern is, does the data appear normally distributed? We are now going to use the Shapiro test to assess that. We want the p-value from the Shapiro test to be at least 0.05. That is what's going to allow us to assume that that normality requirement is met for that sample. That is what happened here with the weekend sample. Again, the primary concern, does the data look normal? From the weekday sample here, it did not appear normal. Okay, now is when we can check on sample size. So even though the weekday sample was not normally distributed because that Shapiro p-value was small, we will be able to proceed because the sample size is at least 30. This is spelled out in the first example of Lab 8. There are other requirements that need to be met for the t-test, and so we would need to assume that the samples were randomly and independently selected with independent observations. The requirements state all of this, right? Random samples, independent observations. We can also have an experiment, a randomized experiment. So that information will hopefully be given to you, and if it is not, then just assume so. It is this next step that requires a little bit of work, by utilizing this Shapiro test for normality. In the next video, we'll go through an entire example of the t-test with this data.